most consequential sound in the history of flying is not an explosion, it is a squeal. A flat electronic tone about 4 seconds long in the cockpit of a Boeing 747 on a fog-bound runway in the Canary Islands. At the moment that tone played, 2 separate people were transmitting 2 separate warnings on the same radio frequency. One was a control tower saying stand by. The other was a second 747 saying it was still on the runway. Both messages were spoken. Both were transmitted. Both were correct. Neither arrived. The 2 radio signals collided in the air and canceled each other into a single useless noise, and the crew who most needed to hear them heard a buzz instead. This is the story of 27 March 1977. It is usually told as a story about an arrogant captain, or a bomb, or fog. It is none of those. It is a story about how 2 aircraft full of people can be destroyed by nothing more exotic than 2 human beings speaking at the same time. Start with the fact that neither aeroplane was supposed to be at this airport at all. The destination was Gran Canaria, Las Palmas, the main airport in the islands. That morning, a separatist group called the Canary Islands Independence Movement detonated a bomb in the terminal there. The airport closed, and every aircraft inbound to Las Palmas had to go somewhere else. Somewhere else was Los Rodeos. Los Rodeos is a secondary field on Tenerife, sitting at 633 meters of elevation, which matters more than it sounds. That altitude puts it in the path of cloud that would pass harmlessly over a coastal airport. It had 1 runway and 1 parallel taxiway. It was built for the traffic of a quiet island field. By early afternoon, it was holding aircraft it was never designed to hold, including 2 Boeing 747s, the largest airliners in the world. The diverted aircraft parked where there was room, and where there was room was the taxiway. Hold that thought, because it is the whole accident in one sentence. The taxiway was full, so departing aircraft had to taxi down the runway itself. Not alongside it, along it. Nose to tail, on the same strip of concrete they would shortly be trying to take off from, all the way to the far end, and then turn around. It is worth sitting with what that involves, because the word taxi makes it sound trivial. A Boeing 747 of this era is around 70 meters long with a wingspan of about 60. It weighs, loaded, something in the region of 300 tons. It is steered from a flight deck 3 stories above the ground, and the pilot sitting up there cannot see his own wingtips, his own wheels, or anything closer than some distance ahead of the nose. Turning one around at the end of a runway is not a maneuver you perform. It is a maneuver you commit to, a slow, wide, deliberate pivot using most of the width of the concrete, which you cannot abort halfway through. 2 of those were on this runway, in fog, in sequence. At a normal airport on a normal day, an aircraft never occupies the runway except to use it. On this afternoon at this airport, that separation was gone. Everything after this is what happens when you remove that margin and then remove the ability to see. The fog at Los Rodeos did not roll in and settle. It came in patches, drifting across the field at speed, and this is the detail that makes the next 20 minutes possible. Visibility went from roughly 500 meters to under 100, and back and down again. There was no single moment when someone could say, "It is now too foggy to operate." What it produced instead was a specific and unusual condition. The tower could not see either aircraft. Neither aircraft could see the other, and neither aircraft could see the tower. 3 parties on one runway, in one of the most demanding situations in commercial aviation, and the only thing connecting any of them to any other was a single radio frequency. Everything anyone knew about where anyone else was, they knew because someone said it out loud. That is a system with no redundancy. It works perfectly. Right up until the moment 2 people speak at once. Meanwhile, a second pressure was building, and it was made of time. Dutch duty time regulations had been tightened that year. Crews now had hard limits on how long they could legally remain on duty, and the penalties for breaching them had teeth. The KLM crew had been on the ground for hours they had not planned for, and so a decision was made that seemed prudent. Rather than risk a delay later, refuel here at Tenerife before departing. It was a reasonable choice made for a reasonable reason. It also added something like half an hour to the delay, and it added weight to an aircraft that was about to need to get off the ground in a hurry. Nothing so far is a mistake. Every single decision to this point is defensible. That is the point. The captain of the KLM aircraft was Jacob van Zanten. He was 50 years old, and he had about 11,700 flying hours. Here is the part that most retellings skip, and it is the reason this episode exists. He was not a cowboy. He was not a marginal pilot who slipped through. He was KLM's chief flight instructor, the most senior training pilot in the airline. The man whose job was to teach other captains how to fly this aircraft and to decide whether they were good enough. His face had appeared in the airline's own advertising. If you wanted to build the safest possible crew, on paper, you would build this one. So when the popular version of this story reaches for the word arrogance, it is reaching for the wrong tool. Arrogance is a personality. It is comforting because it is rare, and because you are not arrogant, and so this could not happen to you. What actually failed here was not a personality. It was a connection, the link between one human being and another, and between a person and the information they needed. The most senior instructor in the airline made this error, not despite his seniority, in part because of it, because seniority in 1977 meant something in a cockpit that it does not mean today, and we will come back to that. Both aircraft are now on the runway. The KLM 747 has backtracked to the end, turned around, and is lined up facing down the strip, engines idling, waiting. The Pan Am 747 is still on that same runway, some distance behind, taxiing towards an exit it is looking for in fog. The tower knows both of these things. The tower cannot see either of them. At 6 minutes past 5 in the evening, the KLM first officer reads back the route clearance, and at the end of the read back he adds a phrase. Roger, sir, we're cleared to the Papa Beacon flight level 90, right turnout 040, until intercepting the 325 and we're now at takeoff. We're now at takeoff. That is not standard phraseology. It never was, and it has two readings. It can mean we are at the takeoff position, we are lined up, ready, waiting for you. Or it can mean we are taking off right now this second. The tower heard the first, the captain meant the second, because underneath that transmission on the flight deck Van Zanten had already said, in Dutch, we gan, we're going, and then check thrust. The aircraft is already accelerating. Now watch what the system does. It works. It very nearly saves everyone. The tower responds immediately. Okay, stand by for takeoff, I will call you. Stand by. The correct instruction given in time. And at that exact instant, the same second, not the next one, the Pan Am first officer keys his microphone and says, and we're still taxiing down the runway, the Clipper 1736. Also correct. Also in time. Also exactly the information required. 2 transmissions, 1 frequency. Same moment. And here the accident stops being about aviation and becomes about physics. Aviation radio of this kind works by having one person at a time impress their voice onto a carrier wave at an agreed frequency. The system has no way to cue anyone. It has no way to say someone else is speaking. It assumes, as its whole design, that people will take turns. When 2 transmitters key up together on almost, but not exactly, the same frequency, their carrier waves do not politely interleave. They add together. Where the 2 waves are in step, they reinforce. Where they are out of step, they cancel. The difference between the 2 frequencies emerges as a new tone of its own, riding over the top of everything. That tone is called a heterodyne. Pilots call it a squeal, and every pilot alive has heard one. It is the sound of 2 people transmitting at once, and its defining property is that it does not merely make the messages hard to hear. It destroys them. The information is not buried under the noise. There is no version of the recording you could clean up, no filter you could apply. 2 correct warnings entered the air, and what came out the other side was a tone carrying nothing at all. The transcript records it plainly. The communications caused a shrill noise in the KLM cockpit, and the messages were not heard by the KLM crew. Read that again, because it is the entire accident. The warning was given. The warning was correct. The warning was not received, not ignored, not overruled, not missed through carelessness. Cancelled by physics in the air in the space of about 4 seconds, because 2 people who were both doing their jobs properly did them at the same time. There is one more chance. It comes from the 3rd seat. To understand what that seat could and could not do in 1977, you have to understand the shape of authority in a cockpit of that era. A flight deck is not a group of colleagues. It is a hierarchy, and it exists for a good reason. In an emergency, someone has to decide immediately and everyone else has to act. A command structure is not a flaw in aviation, it is a safety feature. But a hierarchy has a gradient. And the steeper it is, the more energy it costs someone at the bottom to push information upward. In 1977, that gradient was close to vertical. The captain's judgment was the final word by design and by culture. And the further you sat from the left seat, the more certain you needed to be before you spoke. Because being wrong in front of the captain carried a real professional cost, and being right carried almost none. Now put a specific man in that structure. The captain in this particular left seat is not merely a captain. He is the man who examines captains. He decides who is qualified to sit there at all. Behind him sits the flight engineer, and the flight engineer has heard something that does not add up. He does not have a clear picture. He does not have evidence. He has a doubt, and he says it out loud. Is he or niet afdaan? Is he not clear then? That is the sound of the safety system working exactly as designed. A crew member with less authority than the captain, less experience than the captain, and no clear evidence, raising a concern anyway to the most senior instructor in the airline during a takeoff roll. He should not have had to be brave to do that. In 1977, he did. The answer came back in a single word, jowl. Oh yes, emphatic, certain, final. And that is where it ends because the flight engineer did what the structure of that cockpit told him to do. He accepted the answer of the man who taught captains how to fly. Somewhere ahead in the fog, the Pan Am crew see landing lights coming towards them out of the gray. And the Pan Am captain says the last thing anyone says that is not a scream. Got him. That son of a bitch is coming. From the flight engineer's question to the collision is 11 seconds. 11 seconds is not enough time to stop a 747 at takeoff speed. It is enough time to have a short conversation. It is roughly the length of this sentence, spoken twice. The last thing on the KLM cockpit voice recorder is the captain's voice, and it is not a word. 583 people did not survive that evening. It remains the deadliest accident in the history of aviation. 61 people lived, all of them from the forward section of the Pan Am aircraft. The Spanish Civil Aviation Authority investigated, and its finding of fundamental cause is a single sentence. The KLM captain began the takeoff without clearance and did not obey the tower's instruction to stand by. That is true. It is also, on its own, useless. Because if the lesson of Tenerife is the captain shouldn't have done that, then the lesson is that one man made one mistake, and the fix is to not have that man, which fixes nothing and protects no one and would not have prevented a single accident since. It is worth knowing that the investigation did not end in agreement. 2 reports were published in 1978. One was the Spanish-led International Commission. The other came from the American Airline Pilots Association, and while it did not dispute what happened on the runway, it weighted the contributing factors differently. That disagreement is not a scandal, and it is not a cover-up. It is what happens when serious people look at the same evidence and argue about where a chain begins. Because you can start the chain anywhere you like. Start it with the captain releasing the brakes, or with the phrase "we're now at takeoff," or with the 2 transmissions colliding, or with a runway being used as a taxiway, or with an airport that was never built for this, or with a bomb in a terminal on another island that morning. Remove any single one of those and everyone lands safely. That is the actual finding, and it is the one that generalizes. Not a man made an error, but that a long line of individually survivable events had been allowed to run in series, with no mechanism anywhere along it capable of stopping the line. The investigators understood this, and what came out of Tenerife was not a punishment. It was a redesign of how people in aviation are permitted to talk to each other. The first change was to the language itself. The word takeoff was taken away from everyone. It now appears in exactly one place, the actual clearance to take off. At every other moment in a flight, planning it, taxiing for it, talking about it, the word is departure. So the sentence "we're now at takeoff" cannot be constructed anymore. The ambiguity was not clarified. It was deleted from the language. Okay went too. It is not an acknowledgement, because it does not prove anyone understood anything. Redback discipline was tightened so that a clearance is not a clearance until it has been repeated back correctly. Those are small changes. They are also why you have not heard of a repeat of this accident. The second change was larger, and it is the reason this episode is in this series. In June of 1979, NASA convened a workshop at Ames Research Center called Resource Management on the Flight Deck, chaired by John Lauber. The research behind it had reached a conclusion the industry did not particularly want. The dominant causes of airline accidents were not failures of flying skill. They were failures of interpersonal communication, of leadership, and of decision-making. Not hands, people. United Airlines ran the first comprehensive American program built on that finding in 1981. It became known as Crew Resource Management, and today it is trained, examined, and mandatory across commercial aviation. Strip away the acronym and CRM says one thing: a junior crew member can challenge the captain, and the captain must answer the challenge, not the person. That second half is the part people miss, and it is the part that would have mattered here. The flight engineer's question was not answered. The questioner was answered. "Oh yes" is a response to a person. It settles who is in charge, and it settles it correctly, and it transmits no information whatsoever about whether the runway was clear. Under CRM, that exchange has a required shape. A doubt raised is a doubt that has to be resolved out loud, with reference to something real. What was heard, what was seen, what was confirmed. Not because captains are untrustworthy, but because certainty in one person's head is not evidence, and a cockpit is supposed to run on evidence. The discipline goes further than words. It flattens the gradient deliberately, briefing crews so juniors are told in advance that speaking up is expected, not tolerated, giving them fixed phrases that escalate a concern without it becoming a challenge to authority, and training captains specifically and repeatedly to receive that input without defending their own status. None of that is about being nicer. It is engineering applied to a human interface. The industry looked at a fatal accident, identified the failing component as the link between two people, and redesigned the component. That is it. That is the entire doctrine. And it exists because of 11 seconds on a runway in the Canary Islands and one man in the third seat who asked the right question and got one word back. He did the hard part. The system did not support him, so the system changed. If you watched the episode on Air France 447, you already know why this one matters. 32 years after Tenerife, two qualified current, healthy pilots sat 18 inches apart in a serviceable airliner over the Atlantic. One was pulling back. The other did not know. Their controls were not linked, so there was nothing to feel, and in the noise and the alarms, there was nothing said that reached the other man either. Same failure. Different century. Different machine. Tenerife is where aviation learned that the gap between two people in a cockpit is a place where accidents live. It responded better than almost any industry ever has. It rewrote its own language, and it built a discipline whose entire purpose is making sure a quieter voice can reach a louder one. And it is still not finished. Because the problem was never a bad captain, or a bad aeroplane, or bad weather. The problem is that two people can both be right, both be speaking, and still not reach each other. On the 27th of March, 1977, that took 4 seconds.